In this presentation, we're going to look at binary classifiers such as logistic regression and so on. And what we're going to do is look at model metrics that are used to assess how good a binary classifier is. So a binary classifier is a sort of mathematical system that results in either a yes or a no, 0 or 1 answer. Now sometimes it's the correct answer, sometimes it's not. So here's the sort of framework. So essentially what we're looking at is a thing called accuracy, precision, and recall, and also later on something that combines precision and recall called the F measure down here. Okay, so essentially a binary outcome. So what we could do is actually state that some outcomes are negative and some outcomes are positive. Okay, so like a Bernoulli trial essentially. And what we will know is that some are, we will be able to observe them, what the true answers are. Okay, observed negative, observed positive. So essentially what we do is we build our binary classifier, and it will predict either a negative result or a positive result. Okay, so if something is observed negative and we predict it to be negative, that's a true negative. If something is observed negative but we predict it to be positive, that's a false positive. Likewise, if it's observed positive and predicted to be negative, false negative, and then we correctly identify a positive outcome, and when we know it's positive, that's a true positive. Okay, so these are correct predictions, correct classifications, whereas what we have here are incorrect predictions. Okay, so essentially what we want to get is an overall picture of how well we're doing. So Fn, Pn, Tn, and Tp. False positive, true positive, so on. Okay? So it's straightforward enough. So we have three metrics to begin with. Accuracy. Okay? And that is the number of true correct predictions over the total number of predictions. Okay? Correct predictions, true positive, and true negative. Okay? So those will be the ones that we are essentially along the diagonal here. Okay, out of the total number. So it's a straightforward number to calculate. Then what we have is the precision. Okay, so what we're going to do here is look at the last column here, what we predict to be positive, and essentially out of that, what is the proportion of true positives out of the total number of predicted positives. And then what we have is the recall, finally, and this is the total number of true positives out of all of the observed positives. Okay, so essentially what we're doing is disregarding the true negatives and just looking either the predicted positive column and the observed positive column, and just sort of assessing how many were correct in both of those cases. Finally, what we have is the F measure, and this is essentially a way of combining the two results. This is a harmonic mean of precision and recall, if you're interested in that. But the way we calculate it is 2 times precision times recall divided by precision plus recall. Okay. So I'm going to go down here to the question, the exercise that we were asked to do. So we have observed negative, observed positive, predicted negative, and predicted positive. And altogether, there are 10,000 cases here. Okay? Now, so we have 4 scenarios. And this scenario here is the observed negative, predicted negative. And in that scenario, we have 9,530 cases. Okay? Now, this is by far the largest of the 4 scenarios in terms of numbers. And the reason is that quite often when we build a predictive system that will create a binary classifier, the negative results are sort of easier to spot, so we don't actually gain anything by correctly identifying negative results because they're probably easier to spot, whereas the positive results are probably of more interest or more value. So this is known as class imbalance. Okay, so we have 9,530 here, 160 here, but overall we feel that this 160 is more important because it's what we're trying to catch. Okay, so accuracy combines these two results into a single value. So the true positives, 160, plus the true negatives, 9,530. Altogether that will give us 9,790. There are 10,000 cases altogether, so that works out to be 97.9%, 0.9790. Okay, straightforward enough. So it seems good, but, let's look at precision and recall. So precision is looking at how our predictions are doing. Okay, so we make 170 positive predictions. Okay, 10 plus 160. And out of that 170, 160 are observed to be positive. Okay? So we are 95% sure that if something is predicted positive, that it actually is positive, which is great. Okay? So that's 0.9411. Okay, 160 out of 170. But we want to catch as many positives as possible. Okay? So we essentially want to do as well as we can at finding out if a positive observation can be classified correctly using our system. So here we're looking at the recall. So this is the number of true positives divided by the total number of observed positives, the true positives and the false negatives. So we have 160 observed positives, but we only correctly predict 160 of them as such. So of the total number of observed positives, we're only correctly predicting 34.79% of them, 0.3479, as positive. Okay, so that's not so good. Okay, so the F measure is essentially a way of combining the precision and the recall. Okay, so F equals 2 times precision times recall divided by precision plus recall. 2 times 0.3479 times 0.9411, that gives us 0.6548, divided by the precision plus recall, 0.3479 plus 0.9411. Okay? Well, actually, that's actually recall plus precision if we're being correct. Anyway, it doesn't matter. Essentially, you add them and multiply them out. So what we have here is 0.6548 divided by 1.2890. And that works out to be 0.5079. Now, essentially, the F measure is a value we want to be as high as possible. And I think the maximum possible value is 1. Yeah, it is 1. So essentially, it's not exactly a percentage, but essentially you can sort of treat it as if it's an exam score. Okay, so you just sort of get 50% in your exam. That's it, not the worst, but you really want to do better. So what's letting you down is the recall. Okay, so you really want to be catching more of the observed positives, because you're only catching about 1/3 of them. Okay, you want to be doing better there. All right, we'll leave it there.